Good day, everyone.
Good day, senior.
My name is Precious Ojigoro, and this being SS3 week, I'm here to teach you chemistry on the topic types of chemical reactions. Now, a chemical reaction is a change in which new substances undergo to form a given product. That is, one substance and another substance, they undergo changes to form a given substance. Now, to understand chemical reactions, we have to list out the types, which are combination, decomposition, thermal dissociation, catalytic reactions, reversible reactions, displacement reactions, and redox reactions. Firstly, what is a combination reaction? From the name, combination reaction implies that one substance combines with another substance to form a given substance. That is, 1 plus 1 gives you a given product. For example, the combination of hydrogen gas and chlorine gas will give you hydrogen chloride gas. This implies one substance combines with another substance to form a given substance. Then we have decomposition reaction. In decomposition reaction, a bigger substance breaks down to form two smaller substances. Now, when it is required for decomposition to occur, it is called thermal decomposition. For example, the decomposition of lead to triazonitrate 5 salt. Since it is thermal decomposition, what do you require?
Heat.
Now let's work this together. How many lead do we have here?
2.
So, yeah. 2 here. How many oxygen do we have here? 3 times 2, 6 times 2,
12.
So, how many have I put here now?
2.
Plus. Now, how many nitrogen do we have here?
4.
4. So, 4. And if I put O here, how many do we have left?
4.
So, if I put 2 here, how many do we now have left?
2.
Okay. Plus O2. With this, we'll be able to balance this equation. So this is the thermal decomposition of lead 2 triazonitrate 5 salt. Next, we have thermal dissociation. Thermal dissociation is like decomposition reaction, but there are two unique characteristics of it. That is, this thermal dissociation requires heat, always requires heat, whereas decomposition can require heat or not. Also, thermal dissociation is a reversible process. The products can combine together to form the reactants back. For example, okay. So this is the thermal dissociation of calcium triazocarbonate, hydrogen triazocarbonate 4. Now let's check whether they are correct. How many calcium do we have here?
1.
How many calcium do we have here?
1.
So that is correct, right? How many hydrogen do we have here?
2.
How many hydrogen do we have here?
2.
So that's correct. How many carbon do we have here?
2.
How many carbon do we have here?
2.
How many oxygen do we have here?
6.
How many oxygen? 3 plus 1, 4 plus 2, 6. So that is correct, right? This is the thermal dissociation of hydrogen triazocarbonate 4, because in the heat, when it's hot, it decomposes to give you this, but when it's cold, they react back to form this. This is an example. Hope you understand.
Yes.
Then we have catalytic reaction. Catalytic reaction is a reaction in which a catalyst is used to gain the product. And what is a catalyst, first of all? A catalyst is a substance that speeds up or slows down the rate of a chemical reaction. Catalysts that speed up the rate of a chemical reaction are positive catalysts, while catalysts that slow down the rate of a reaction are negative catalysts. For example, okay. Now this is an example of positive catalysis. First of all, let's work out the reaction. How many nitrogen do we have here? How many do we have here? How many hydrogen do we have here? How many hydrogen do we have here?
3.
So it is not balanced. What if I put 3 here now? How many hydrogen do we have here?
6.
If I put 2 here, how many hydrogen do we have here?
6.
If I put 2 here, how many nitrogen do we have here?
2.
So now let's calculate. Two nitrogen here, right?
Yes.
2 nitrogen here. 6 hydrogen here. 6 hydrogen here. So the reaction is chemically balanced. So this is an example of positive catalysis because vanadium 5 oxide it alters reaction so that the rate at which reaction it happens is faster. But negative catalysis, for example, now this is an example of negative catalysis because tetraoxophosphate 5 acid it hinders the reaction, so the rate at which hydrogen chloride gas is produced is slower, it is reduced. Now we have reversible reaction. From the name, reversible reaction is a type of reaction in which the products they can react back to form the reactant. For example, this thermal dissociation process is an example of a reversible reaction, and reversible reactions they are always illustrated by this sign. It's an example of a reversible reaction because here the products here they can react back to form this.
As a parent, I have always asked, how can I prepare my children for the infrastructural development and socio-economic evolution of the next decade? With the ongoing speed of globalization, how can I position my children to perform excellently in a rapidly changing society? The answer is and has always been to give them a solid foundation. Academically, spiritually, and morally. Salvation International Preparatory Schools, with her team of highly qualified tutors, conducive environment for learning, state-of-the-art computer and science laboratories coupled with quality day and boarding facilities, is the place to be. For more information, contact 080-233-76135. SIPS remains the birthplace of leaders.
A reversible reaction is a type of reaction in which the products can combine again to form the reactant. And this reversible reaction is represented by this sign, this. This indicates the forward reaction, while this indicates the backward reaction, obeying the law of Lechante's principle of equilibrium, which states that if there is any external constraint on an equilibrium position, e.g. temperature, concentration of reactants, or pressure, the equilibrium position will shift in order to annul the constraint and to remove it. For example, if this is for example now, for example, if there is increase in temperature in this reaction, because the reaction is exothermic, as seen by this minus sign, the equilibrium position will shift to the left in order to annul the increase in temperature, because equilibrium reactions, everything has to be the same, both the forward and the backward movement has to be the same. That's for reversible reaction. Hope you understand.
Yes.
Okay, then we have displacement reactions. Displacement reaction is a type of reaction in which one element or radical replaces another element or radical in a solution. Now, the rate of displacement is affected by a factor known as the electrochemical series. The electrochemical series is a list of atoms of elements that can displace each other in electrochemical series. For example, now let's be given a reaction like this: zinc plus hydrogen chloride gas Now let's see in numbers here. Now anytime we are doing reactions, this is number 1, number 2, and number 3. Now let's react it. Now since this is a displacement reaction, zinc will not go to hydrogen. Hydrogen is lower than zinc in the electrochemical series, and so zinc will take the chlorine from it and then leave hydrogen alone. That is the aim of displacement. That means one element replaces another element or radical in a series. Let's go. So zinc will go to chlorine, 1 goes to 3, 2 stays alone. Zinc. How many chlorine do we have here? 2. 2 here. Plus hydrogen, how many do we have here? 2. That's H2. So from this we have seen that zinc has displaced hydrogen from hydrogen chloride gas. 7, and the last we have redox reaction. Redox reactions are a bit complex. They are a bit complex, but they are very easy to understand. Redox reactions are reduction reaction and oxidation reaction. Now, the definitions of reduction reaction. Reduction is, according in the basis of electron gain, electron transfer. Reduction is the process of electron gain, while oxidation is the process of electron loss. Now, redox reactions involves reduction process and oxidation process, because one loses, as one loses, another has to gain it, and so that's why these two terms come in equal concentration. Now, for example, the reaction between.
As a parent, I have always asked, how can I prepare my children for the infrastructural development and socio-economic evolution of the next decade? With the ongoing speed of globalization, how can I position my children to perform excellently in a rapidly changing society? The answer is and has always been to give them a solid foundation. Academically, spiritually, and morally. Salvation International Preparatory Schools, with her team of highly qualified tutors, conducive environment for learning, state-of-the-art computer and science laboratories coupled with quality day and boarding facilities, is the place to be. For more information, contact 080-233-76135. SIPS remains the birthplace of leaders.
Salvation International Preparatory School. Salvation International Preparatory School. A place